Okay, hello everyone. Welcome to another design review for Wolfram Language, heading for version 13.1. And I gather this is the 600th live CEOing live stream episode that we have transmitted. That's an awful lot of time spent reviewing Wolfram Language. Put a lot of work into it. It's always good to hear when people appreciate all that work. But it's fun to do as well. Okay, let's see. What are we looking at today? We had gone through many of these pieces. We were talking about, we finished down here, arc through and spatial point data, had we not? And we were talking about, oh yes, we were talking about this interactive graph layout. And I had asked that we review this with some folks from UX and design who are not here. So what happened with that?
It's me.
But
that's me.
Well, okay.
It's the wrong time of the day for UX people. It's UX people are on the wrong side of the world for this meeting.
Okay. Well, then we better reschedule this part.
No, but that's why I'm here.
Okay.
That's exactly why I'm here.
Okay. All right. So how should I do this? I should say,
so I mean, this is example.
Can we at least see if Jeremy is available for design?
Yes, I'll see if I can get Jeremy in.
Okay, so if I say random graph 40, 80, editable true, is that going to work?
Yes.
Okay. All right. So first point here is this selection. Wow, what the heck is that? Okay, this is bonkers, right? What's happening here? Why is my...
Yeah. So you ended up hitting the resize knobbies. At least I'm pretty sure that's
so what should happen here is when I click like that, okay, I should just be getting the node. If I click again, I know what I'm getting when I click again here. The way that selection works normally.
So right. This is the generic graphics selection, and yeah, you're getting the reshape selection here, which is
right.
Which is not what you want.
Right. So is that fixable?
With a bit of work in the front end.
Okay. So that's what's necessary to make this
yeah, I mean, basically we just need to enable an alternative selection mode in a given graphics that that removes the resize handles. I assume that we don't want resize handles. So I mean, if you do a drag selection on some nodes or whatever, I assume then you only want to translate them. You don't want to resize them, right?
Yeah, we don't want to resize the individual node. I mean, what we might want to do as a luxury item is to be able to double click to go into a node to start doing stuff with it. But the generic action for a node...
Well, so define stuff. What do you mean by stuff?
Graphics editing in it. I mean, going in and editing text and God knows what else. I don't know. I mean, I'm saying in...
Well, so I mean, there's a bit of a danger there. I mean, imagine these nodes are text, and I mean, instead of being graphical entities, they're, letters or something like that. And then, I mean, just in the same way that you double clicked and you got into the reshape tool, well, you can double click and get into text selection and once again, not be what you wanted.
Okay, listen, the single click should just move the node around as a unique atomic thing. Okay. Double click, if there is something clever we can do with that and it requires careful UX thinking, great, but that's a luxury item.
Yeah. And, I mean, this is not, I mean, I see this issue even with, other illustration software. It's like, I want to select the block of text, as a whole, or I want to select the text inside of it. And how do I distinguish which
my opinion
action
is
I want to do?
Ultimately, what should happen is you click, and there should be some little knoboid that comes up that you could hit that would give you a menu of things to do. But that's a luxury item.
Yeah, and that's definitely not happening for 13.1.
Yeah, I know. So I'm not asking for it. I'm asking for this case. You hit it, it selects the node, you can drag the node around.
Yeah,
that's it.
Yeah, and that's doable. It's just,
okay,
going to require some front end work.
Okay, so what should it look like when you selected it?
So, well, I mean, my defaults.
And by the way, also a single click is not selecting it. A single click is doing this weird thing. What the heck is that?
It's a graphic complex. You can have a group of graphs, right?
We're not going there. If you click one of these things, you're going to get the damn node. We're not going there. We're not going into something where you're giving footnotes about what.
I agree. I'm just explaining.
No one is fighting you on this, Stephen.
Okay, all right, good.
You asked for an explanation and you got one.
Okay, fine.
But sorry, what was I going to say? The what should the selection look like? My default would be to just make it look like it does now, but without the knobbies. But I'm open to other ideas. Which is to say, the purple.
Yeah, I understand that it has a rectangle. I don't think that's obviously silly. Did Jeremy join us? Does he have a better idea?
Just joined and I heard silly. I didn't hear the rest of it.
Okay, all right. So this is about graphics being able to do this. Isn't that Fantastosaurus?
Yeah, that's great. Yeah.
I've got several questions actually for Charles and so on. I mean, this is really nice functionality to have this. But the problem is when you click to select a node, how should the selection look?
That looks like you could stretch the node, which
you can,
good reason.
Unfortunately.
Oh right. Yeah, well, you shouldn't.
We want to disable that. So I don't think it needs that box necessarily, right? That single center mark, maybe?
I don't think it won't be enough. You won't see where it is.
There's also the issue of if you drag select several nodes, I think you want to see the full box. And maybe Stephen, you could do that just so we can see it.
I don't think you can because it's panning in that case. Oh, it is. Okay.
No, it works. I mean, it's the same.
Okay.
Yeah.
Ignore me.
Yeah. So
I don't know what do I do? So I select them there. So I'm selected. I'm a happy person. Now how do I drag them?
I think if I recall correctly, I think you have to drag on the ink somewhere.
Right. So it have to hit the vertex one edge. Otherwise it's
no, not that.
Yep.
There.
Yeah.
Well, that's magnificent. Except that it required, 10 years of experience or something to actually know what to hit. Yeah, well, it's lovely. Okay, so that's the second case. So what is the analog here? The analog here is, I mean, in a graphic, it makes sense because you're going to be able to edit that piece. In text, we just do inversion, there's an inversion color. Right?
It's not always.
No,
it's actually never inversion, but
what
yes,
is it actually these days?
Well, it's different on fundamentally different Windows versus Mac. On Mac, it is a highlight color that does not change the text color at all. Okay. On Windows, in fact, it actually changes the text color, so it's like blue background, a more solid blue background, but then the text changes to white.
Okay. Well,
Those could technically be images too, though, right? They could really be anything for a vertex. This is the default, but
yeah, and I mean, and in fact, you've got to have something that extends beyond the vertex. You've either got to put a wash on top of the vertex somehow, or
So one of the things I pointed out before you joined, Jeremy, was the very real possibility that the nodes could in fact be textual. They could be letters or numbers, or words.
or there could be nothing there, or they could just be the
That's true. Yes, that's true.
If I do this thing here, oops. Okay, now that edit case, that case where it's all right. It did the right thing because we had edited it. I'm not complaining about that. So if I say here.
Now, but that raises, I mean, that raises a very interesting question.
Good luck on me being able to. My 10 years of experience is not enough now to actually be able to select that node.
So what I was going to suggest as a possibility is that we go with the rectangle, but we draw it with a little bit of padding around the object, and then use a wash behind, so you get like a light purple background.
Yeah, I think that's a good idea. I think that having that border, and then a purple, and then a washed purple, so to speak, interior.
maybe a rounded rect. Definitely no, drag corners.
Oh, that's an interesting idea. Could we do that rounded rectangle?
Yeah.
Will it look like a button? Will it end up looking like
I am concerned about that. Yes.
I just don't want them to, if it's too similar to this, it feels like you might stretch it or, scale it.
When you say rounded, you mean it can like a really tight rounding, like
yeah, pretty
tight.
I've got a different idea, Jeremy. What about a circle? What about something that is very rounded?
Well, you got text, you have images.
No.
Okay, how about a rounded rect with a lot of rounding? If you get what I'm saying.
Okay.
So one of the problems with that is that you might have something you selected that is now outside the rectangle, or you have to buffer the rectangle to account for that possibility.
Okay, I understand your claim. So let me understand what you're saying. So you're saying, how do I make a rounded rectangle?
You can just use framed of I don't know, just framed of like a graphic, and with rounding radius, make it 20.
Okay. So does this rectangle, is there a configuration in which the rounding will slice off a piece of the actual content? Or is the rounding such that the rectangle is drawn? I see. If I made it tighter, then this would eventually chop off.
I don't remember exactly how framed works in this regard.
It has default padding, so you'd have to remove it to see if that works.
but yes, you're identifying the point that I'm concerned about, though.
I think it's frame margins goes to 0. Yeah.
I see. That's getting marginal at best.
Nice pun. You get rid of the margins, and it becomes marginal.
Right. Right. I think with the right coloring, this can be made to not look like a button. And I think having the continued rounding, not, you know what I'm saying? Having more rounding will make it look, because in the case of a circular node, what we really want is that this is just a super node. You see what I'm saying? In the case of a circular node,
super node.
Well, I mean, it's just bigger than the node, right? It's just an enclosing circle around the node that is also circular, as circles are.
Okay. But I
What were you
mean,
saying?
are we optimizing for that case? I'm a little concerned about that.
I think that the rounded rectangle, okay, so let's take a look at what will happen there. So, I mean, you're saying if we take a rounded rectangle and we say we have a graphics, how the heck do we do this? How do we do this? I want to.
Well, it's going to be all the way around the graphic.
Okay, so
And
that's no
there
good. So
is
what I want to do is just a style of a filled circle
It comes with line spacing though. Why not a graphics?
because the frame won't go to the side.
yeah, because the frame will be around the rectangle of the graphic.
Okay, so that's what we'd end up with there, and that's really stupid. Oh, that's
Well,
because of the...
it should be clear. It's not getting its full 20. I mean, 20 is a really big number.
Okay, fine, but I mean, in this,
Now it's getting its full 20.
yeah. Well, so the question really is, if we imagine that tightening in, I think that will be okay.
Oh, that's interesting. Should take a look at the example that Brett. Yeah.
That is interesting.
Ooh,
And
what's the,
and it's general.
Can I bring up the drop shadow and make it less ethereal, so to speak? Can I make it less? How do I make it the opacity of the drop shadow? How do I change the opacity there?
You can add the opacity to the, instead of purple, you can replace it with opacity or opacity with color.
No, but I want to make it brighter. I want to make it less, muted. How do I do that?
What? So it's just a 4-value RGB color, right?
Right.
Because
I
the default,
understand,
because by default it's applying opacity of like 50% or something like that. So
I understand, but I'm asking if we made less opacity, right? I'm asking how to make this less.
Specify the opacity to. Right now, you only specify the first three coordinates.
4-value
Oh,
RGB color.
I see. So if I say opacity 1, purple.
Yeah.
So that's why.
Right. Well, I consider it more like a bug in the support.
Okay, can you fix that? But that's just okay. So let's do RGB color. Purple is as RGB1, right?
Yeah, I don't. And no one ever told the front end team to support 2-argument opacity, so we never did.
We should.
There's
Okay,
other
this
ways
didn't work.
to.
This didn't work. How do we make this brighter? You see what I'm asking? I think it's a good idea, but how do we make this stand out more?
The option to do it is an exposed jet. Give me a moment and I'll
Okay, fine.
give you a more complicated thing to.
But Jeremy,
drop
what
in
do you think
place.
about this general approach?
oh yeah, I think it'll work fine. I use this instead of border often for shadows.
I
and
think
HTML.
it still needs. I think it still should have a border around it, but this can be done instead of the background color, though.
But so all this assume that you are selecting the vertex. What about the edges?
This would work great on an edge.
Yeah, I think this will work fine on an edge. How do I select the edge anyway? Oh, I need to go back up here. Oh my gosh. Well, that's really bad way to specify the selection of an edge. Right. It's very Cartesian, but it's not otherwise useful.
Yeah, but once you get 2 of them, then what choice do you have?
You drop shadow both of them. Why not? And then in other words, as you wash over something, you are Avery is asking, is the edge actually colored? And the answer is, well, yes, but it's awfully hard to see that. But I mean, if I go up to here, oops, whatever.
Yeah, you were doing a resize.
Oh, I'm doing a resize because rather than during the initial selection process.
Yeah.
Okay, so there I've got many edges selected. Do I also have vertices selected?
Yes, you have both.
Yes.
Okay, so there I go. But right. But this is essentially like a constrained drawing story.
Yeah.
This is quite lovely. I mean, this will have a big effect on lots of random pictures that we make. Okay. I'm going to tell you some other things that I know people are going to want. They're going to want to be able to adjust where the vertex label goes. I mean, in general, with labels, they're going to want to just move a label around. The other question is, when I get back this graph, okay,
I think
Charles,
these can be fine extensions for future.
great. What was that? Oh, yeah. Well, I'm not asking for this version, Roger. What's that?
No, I didn't quote the expression back yet, so it just fell.
Okay, but that we do need.
Yes, it will work.
Okay.
The thing I was
Okay.
trying to do isn't working for some reason, so.
All right, fine. All right, so we need to iterate this again, but we get the basic idea. Drop shadows. We're going to go to an edge. Now, what happens if I've got selected an edge? What can I do if I select an edge?
But right now you can move the edge.
You can
How
delete
can I
it.
move the edge?
I think you can delete it.
No, like above, you just, if you select the edge, you.
Well,
moves the connecting
I think Steven's point is, how can you do something with an edge without also doing something with the nodes at either end of the edge?
You can't.
You can't. I mean, that's
Right.
Yeah,
Okay. So for right now, let's just select nodes. Let's not select edges. Unless you think
what am I missing? I mean, that's the expected behavior, right? When you select the.
no, it's not.
No.
It doesn't matter what look. If you select this edge, the thing you'd really expect is to be able to reroute the edge, for example. I mean, what is the delete operation anyway? If I go here, how do I delete that node?
Press delete. No. Reevaluate that object. Your object is now just a pure graphics. Reevaluate the graph, random graph. So you should have a normal deletion of an edge of a vertex. Sorry.
No.
But something is wrong in your build. Normally you should delete.
Maybe it's backspace versus delete.
No, something is just wrong. It's just deleting the box instead of actually the event handler. Something is wrong in the event handler in this case.
Right. And I just wanted to make sure that did you put in event handlers for both backspace and delete, or just one of them?
Backspace.
Well, that's not good enough. Okay. Yeah, you need both, right?
Well, John, we can discuss that later, but it was just mainly backspace which worked. Right? Delete was not.
Okay.
Yeah, I mean, I certainly on Windows, I would expect the delete key to work.
And on Mac. And on Mac. They should both work. They both delete. They should both work. And they sure shouldn't do this.
I've never properly understood the delete key on Mac, which is often not there on many Mac keyboards.
Okay.
So
That case seems like you actually end up selecting inside the box. Maybe I just need to control how far do you make sure that the tag box get the full selection of the object than just the inside.
Look, there's clearly more to do here. I mean, there's clearly something where we'll need an attached menu, and you'll be able to add edges and God knows what else, right?
Right. So that's kind of a long-term plan. Right now, we were just planning to just put a basic graph.
Okay, just do what you have right now. Move a node. Delete a node is luxury. Even delete a node is luxury.
Can you move with a single
Sure.
click? Is that the intent, or do you select first and then move?
No, you should be able to move with a single click. You absolutely, this is nonsense. This panning is just nonsense.
No. Look, you either support drag selection or move with a single click. You can't do both.
And there is also the scenario that you are looking at a graph which is connected here. There are cases where you can have disconnected component and you want to rotate a specific component. You want to enlarge a specific component. So it gets more complicated.
Look, listen. There's a lot that could be done here. It needs an attached menu. It needs much more serious design. This is just a simple version of this. But let's make the simple version work nicely. Okay. And what Jeremy is saying is, do you need to double click in order to be able to move the node?
Or even single click, I think.
Single click.
I was guessing that's what happens. I mean, you could imagine if you have hover over, a node, just drag could work. That'd be ideal.
Yes, but the thing is, even if moving individual nodes is always supported today, that's not all we're supporting in the future, which means it will change. I mean,
Okay, fair enough. Look, I think single click is okay. If on hover, it gives an indication that there is a single clickable thing. You get what I'm saying? If on, yeah, so long as there's an indication on hover, I think it's fine.
So the cursor, is that enough? It will have a cursor effect.
yes.
If there's a cursor effect that isn't this cursor, which is
Well, I mean, the obvious cursor effect would be, either a, like a four-way arrow or a hand. It's something that indicates that you're able to drag it around.
That's fine. I don't like either of those pieces of iconography, but yes, if we have a reasonable cursor there, it seems like the right thing. Then clicking is okay.
Yeah.
Look, for this version, what I think we should do is just support that. Just clicking and moving a node. I mean, for luxury, you can delete a node. What else? What other actions would you like to have? Guys? Charles? What other actions do you think you've already put in?
So, selection, delete, move, resize.
Okay.
So
let me tell you, I just asked you, we need a list of everything you've put in, because I think most of them should not be there for this version, because they will not be right.
Yes, so that's the part I has explained John at the beginning. We have to understand what is not actually that I put in something specific. So if I can allow to actually explain, you saw there, we say is an interactive graph layout editor. So what we try to do is essentially to generate a graph, or if you look at it as a graphic, and let the graphic editor behavior just work on that graph.
I know.
That was the plan we did. So we can try to take off things.
Yes, exactly.
That's fine.
Take off everything.
Yeah.
And that part depends on the front end side. So they have to implement something.
Right. So we remove reshape and we remove resize. And
Nick is asking, how would vertex resizing interact with custom edge shape functions? Like, what if the edge ends at a particular point of a vertex?
They don't. And it's where it actually gets complicated, because an edge can be a disk.
Right. So how about we not support vertex resizing for this version?
I think we're already agreed on that.
We agree on that.
Okay, fine. So the only thing we're supporting is move a vertex and delete a vertex.
And maybe deletion, yeah.
Yeah, those two would be fine. Now,
and implicitly selection.
Yes. Let me ask this question. What about the rerun? Okay, here's a question. How much hysteresis is there? As in, if I wiggle these around, if I move them around, and then I rerun the minimization code, the layout code, will I get the same layout, or might I get different layout? It's like those things. What the heck was that thing called? That thing with springs and so on. And
Right, so it's not dynamically adjusted, no. So this is just a pure, just think about it as a graphic. So
No, I understand. I understand. But you are getting back the graph, right? So given those initial vertex coordinates, you could rerun the minimizer on those vertex coordinates.
yes, but what we will do if you move it and just make the expression out of the whole graph, we actually embed the vertex coordinates. So we don't
I know.
run any label.
I know that. I know that. I know that. But so what I'm saying is at this stage, right, when I've moved something around, right? I moved something around on this one here. And by the way, this interaction we need to understand, right? With canvas, with these editable graphs.
Yeah. I
Just
think
make it do something reasonable for this.
I mean, I think the only you know, what you want to do is essentially have it as a background.
Yeah, that's fine. Okay, that's fine. For this version, that's fine. Okay. Sorry, what were we just saying? We were saying, oh gosh, what were you just saying, Charles, before that?
No, you're saying that we could in principle run the minimizer with
Oh,
from
yeah,
a
yeah,
new initial
right.
value.
Right.
We don't do that now. We have prototypes from long ago when we were thinking of building such an editor.
Okay, so what I'm suggesting is this, okay? I'm not suggesting that once you've hit Shift Enter on this graph, you've got what you've got. It's got vertex coordinates burnt in.
Mm-hmm.
You know what I'm saying? At least, you know, as soon as you've moved something, it's got vertex coordinates. Make sense?
Yes, yeah.
Okay, so now my question is, what I'm saying is that there should be something, an attached cell type thing or something, that you can press a button and rerun the minimizer while you're in this state, while you're in editing state.
Oh, I see. So use the existing position as initial value in the minimizer. I see.
Yes, that's what I'm suggesting. That would be very useful. Probably not for this version, but that will be very useful. Let me try something else here. How does it? Oh God, this is driving me crazy that Command L doesn't work for this. Is that really right, John?
Command L copies down input cells.
Yeah.
If you convert it to an input, then it's an input cell.
All right.
We're working on the mind reading stuff, but we're not there yet.
This is pretty good. This is pretty responsive. How far can I go with this?
That's the whole thing is everything here is a graphics complex, right, Charles?
Yep, just a graphic complex.
So I don't have a.
I mean, it's dragging.
I mean, I can't give you numbers to say for sure, but yeah, I mean, it's, you know, this is in terms of the box construction, it's efficiently constructed. And I think we have a good story in the front end for handling this, and we could probably optimize it a little more, but it's, you know, what Charles is giving us is you know, ideal for these sorts of manipulations.
Okay. If we could get something that would run a minimizer or even run, you know, be able to run different graph layouts here, and we got some UX for that, that will be magnificent.
So, Charles, it's straightforward to set up an attached cell interface that could just, you know, pop up automatically anytime you've selected a graph. Now, the content of that interface, of course, is entirely up to you. But if, you know, when you have something you want to hook up, that's quite straightforward.
So I mean, we need that for region. It's just that we yet haven't had the time and resources to actually build one for graph. I mean, we have some prototypes, so we will do that at some point.
That feature would be just really useful. And I mean, I think what we want is something where there's an icon which means re-minimize, and there's a pull down from that that allows you to pick other methods for the layout. Am I making sense?
Yes, we put that in the list. Yep.
Well, and also giving you the feedback to indicate, you know, what method is in use right now.
Possibly.
You know,
Are you hoping to see?
Sorry.
I was asking, are you hoping to see to move dynamically, or you just want the
No,
results?
I don't care.
Okay.
I mean, it'd be entertaining to move dynamically, but it's mostly entertainment value to do that. I mean, I would expect most of the time, because you'd made a fairly small move, you know, you move particular vertices, right? What's going to happen is it's just going to relax to something. It's not going to be a big wholesale change. It's rarely going to be a big wholesale change. It's mostly going to be the particular vertices will kind of get pulled back into the main graph or something. See what I'm saying?
Yes.
I think it will be just fine to not see the dynamic case. The dynamic case is pure sort of, you know, that's amusing, but it's just not that important, I think. I do think, and I want to say that the general thing of moving labels around is really important. But the problem with that is, here's the thing that is a UX problem that we need to solve. Okay, so let's say you move labels around and you prevent something from colliding. The problem is then I want to regenerate the graphic. And by the way, my labels go in a completely different place in the regenerated graphic. So what do I do? I mean, it's very similar to the calculus of annotations problem. When do I blow away the annotations? When do I keep them?
Mm-hmm. Yep.
And I suspect we should solve it in a similar way. I mean, I think that again, well, separate meeting.
I'm sorry. Is it solved, or
for
you're
calculus
saying,
of annotations?
Yeah.
Somewhat. I mean, we're about to see that actually. You can take a look at that right now because we're about to see that with graph sum and graph join and so on.
Okay.
Okay, I think we're in a reasonable place here. Jeremy can get you some specs, I would imagine, for the and Brett is going to give you ways to be able to give a little bit more variation of the drop shadow, and we should be good from this.
Yep.
People are asking on our live stream for lots of features that I would love to see happen, but they will not happen for 13.1, which is closing, like, you know, the train is leaving the station imminently. They will happen later. Freezing portions and rerouting portions, yes, these are all highly interesting. Beziering the edges, highly interesting, but not for 13.1. For 13.1, we're going to get the most basic thing, which is moving vertices, which is already non-trivial. I also want to see what it feels like to have this editable true mechanism for doing that. And I think that's a correct option name, given our other uses of editable, right?
Yeah.
Seems right to me. Yep.
Yeah. I mean, you could make a counter argument against it, but I wouldn't.
No, I don't think we need to worry. Will there be an option to convert the graph to a mesh that can be manipulated? Not quite sure I understand that. We already have a lot of stuff for dealing with meshes. Okay, let's keep going. Guys, anything else? Charles, Roger, do you want to raise anything else with respect to this functionality? Or can we keep going?
No, this is the beginning, not the end. So
right, it's a good beginning. Very nice stuff. But let's just not overclaim for it, so to speak. I mean, it's just moving nodes. That's the whole story here. That's a nice effect, by the way.
A drop shadow effect, I think, is going to be one of the superstars of 13.1.
Yeah, it's amazing how those things work, like rounded rectangles and things.
Yeah.
I wonder where else we should think about using it. I wonder if there's some, well, anyway, I mean, I wonder about the highlight.
Rounded rectangles are just making it into Qt.
Okay. But listen, in terms of highlight graph and things like this, we should certainly have some examples that show drop shadow effect. Does that make sense?
Yes, we can add some. Yep.
the highlight functions should show those. Okay, spatial graph distribution. Didn't we look at that last time?
Yes.
Yes.
Okay, we were just looking at graph sum.
Yep.
Which I think I understood, and I think I understood that has no annotation keeping. Is that correct? Just blows annotations away.
You have
Yes,
to
I
look at the
understand.
source.
Yeah, okay. And there's no choice about that. Blowing annotations away, that is.
Well, at this time, yes, but we could preserve some annotations, right?
But graph join better preserve annotations. Okay, graph sum. Okay, so first point, I think last time we were objecting to the name. And you were telling me this is the standard name for this.
Yes.
And what we were saying is these graphs, okay, wait a minute. You're saying that the sum is by index number. That is, if the nodes are called A, B, and C, those are not what get combined. It's their position in the index list. Correct?
Correct.
It's better say that, but much more clearly in this documentation. That's a very obscure way to say it. It's very obscure. You should say that the things are ignored. If that's really true, and is that really the right thing to ignore the names of the vertices? It just seems wrong to me. It just seems completely wrong to me. If I was making this, if I was doing this graph sum and I had, flows between this city and that city, okay, and I wanted to combine, people going from Sydney to London or something, right, with people going from there to there, and I combine these frigging graphs and I get completely the wrong thing. Because, one of these graphs might not have one of the indices in it. I don't get it. I don't see how this is useful. Well, let's say that this graph had indices 1, 2, 3, and 4, but this graph only has indices 2 and 4. Then those indices will drop down in the index graph and you're toast.
No, it's resolved. Essentially, the key idea here, really, if you think about it, the same as people, you build the Laplacian graph and such, right? You are manipulating the adjacency matrix, right? You take the adjacency matrix, you add the diagonal and such. So what people wanted is to formally define those operations, right? So we call it graph sum, right? And it operates on adjacency matrix. That's the whole idea.
I understand that, but I don't think it's the right thing. Or at least it's an option perhaps for graph sum, but the much more common case, how do you get the thing that I'm describing? Is it graph union or what? Do you understand what I'm describing? Did you understand what I was describing? So I'm saying I have a graph, A goes to B, B goes to C, C goes to D, for example, okay?
You wanted to sum the flows on edges?
Yes, I want to sum, not on the edges. I want to make new edges, right? Then I have an A goes to B, C goes to E, C goes to B or something. I don't know. Okay, now what do I do with this? Can I say graph union?
Yes.
Okay, with vertex. Is that the right way to do it?
Yes. Stick to argument.
Okay, so did this do what I was talking about, what I wanted?
Well, I'm not sure exactly what you wanted, but
Well, I just want to combine. I want to throw all the edges
So it unified the two A arrow B edges into one, it looks like. Is that what
which
you
is
wanted?
wrong. That's wrong. That's not what I wanted. That's not what I wanted.
not sure what you want, but
I want
that
two
can-
edges there. There are two edges. I want the two edges there.
right. So you wanted to count the multiplicity of the edges.
Well, you could say it that way if you want to, but that's what I would think the graph sum would do. Not some crazy thing with adjacency matrices. If I wanted adjacency matrices, I would ask for adjacency matrices.
Okay.
I don't get this. I don't get it. Maybe there's some definition of graph sum. I don't get it. It just seems like a source of bugs to me. That first of all, somebody will have something which is dense and then graph sum will work, then they'll have a sparser graph and it'll fail.
No, graph sum work on all graph.
No, it doesn't. It does the wrong thing. They'll think they're going to get the thing which takes, in other words, as soon as they delete a vertex from the second graph in the graph sum, okay, all the vertices after that vertex will have their numbers adjusted and they will incorrectly align with the vertices in the first graph.
Agree, like you say, or your intuition, correct. It's possible, but what we are adding here is a well-defined operation, right? So we can decide to drop it because we don't like the behavior of the operation, but that's
Okay.
the operation.
Is it the operation? So if I look up graph sum on the web, I will see something which says it renumbers the vertices. Conveniently, our very own website.
As I pointed out before, right, there is the case that, most of the graph theory and some of the operation are on labeled graph. In the language, we deal with labeled graph. So to reconcile it, in some cases, we just have to get rid of the labels, and then you end up with the indices, right? So that's pretty much what we are doing. We cannot live in both worlds, in the world of labeled graph and unlabeled graph.
Yeah, except for trees, we're doing the exact opposite. We barely have unlabeled trees.
Yep.
Yeah, Sandra is commenting that what I want is graph of the join of the edge lists. Yes, that's right. But I mean, which maybe is the right answer for that. Is graph sum a common operation?
So Stephen,
No,
is the
no,
result of
it's-
what I put in chat what you expect or
It's-
not?
As I said, right, those operations appear like when you do Laplacian graph, Stephen, right? The Laplacian graph is what? The adjacency matrix plus the diagonal matrix.
Yeah, right.
So how do you represent them? Is a graph sum. Simple as that. So that operation appear when you do, or you construct other object, right? Maybe it's not the most standard one you deal with, but it appear, right? I mean, people use it.
But why, in that example, the diagonal happens to span the whole matrix, right? But what if I wanted to take a graph and insert like a Green's function from a graph for a graph, okay? So let's say I have a grid graph, okay, 10-10 grid graph, and I want to insert in the middle of that graph, I want to insert another grid graph right here. Okay, how would I do that? Because if I do a graph sum.
If you want to insert, I mean, so that's a graph transformation. I mean, the graph rewriting, you pick a vertex or a node, and then you define your transformation rule. You shouldn't assume that should be a graph sum. Graph sum is just adding.
Okay, so it's adding on a corner there. Is that correct? I don't know why it did this whole thing. Did you expect it to do the thing it did here?
Yes. So actually, those are the first, the starting vertices. So there should be 5 of them, right? So, then you get that multiplicity. It's like you're adding 2 grid graph, and then the rest remain identical.
Something is fishy here. Look, I don't know how these are numbered. Maybe we should put in the numbering here. So what's happening is this is friggin' weird. Okay, so what it did was it grafted that grid graph there onto this. Oh, that's so friggin' weird. It grafted it onto the right-hand edge because of the numbering here, right?
Right. So the way you can look at it, you take the smallest graph and then you have the big graph. You just map them on top. So you're adding adjacency matrix. Right?
I know.
So it's what happened at the beginning there. So It's pretty much that operation.
This operation is going to lead to a lot of bugs. Why don't you just compute the adjacency matrices and add them? What is this preserving in the graph other than, is it blowing away annotations?
No, at this time, we are not supporting annotations.
No, I understand. So that means this is exactly equivalent to the one-liner of add the adjacency matrices, correct?
Right, it's a little bit more than that.
What more is it?
Well, you have first to convert them to index graph and then add the adjacency matrix and then call adjacency graph on it if you're hoping to get a one-liner. So you have to canonicalize them to graph from 1 to n and then reconstruct.
Yeah, I know. LB is commenting, another definition of the sum of graphs is the smallest graph that contains all the arguments as subgraphs. Right. And that's not the graph union either. Given n graphs, what graph contains all those graphs as subgraphs? What's the smallest graph that contains all those graphs as subgraphs? Charles, does that make sense? It's clearly an answer to that question. I mean, it's clearly a different.
Not sure I understand the question. I mean,
no, that's a definition that this person is making of a graph sum. Okay, do you understand the definition? The definition is you take a bunch of graphs and you ask, what is the smallest graph of which all those graphs are subgraphs? Presumably either labeled or not.
Well, my first intuition, I doubt that is correct. It may be one of the property, but I doubt that is correct.
But what's correct? What are you saying? I mean, the question is, the claim is not that that's the same thing as the sum of the adjacency matrices. See what I'm saying? That's a different definition. I mean, the question is the definition of graph sum. Do we have it right?
Yes.
Nick comments that he's been doing some implementation of graph product. Okay. Without knowing that there's other work being done, let's take a look at Nick's. Nick could join us here if he wants to.
We have graph production version 10. So just for your information.
This graph product?
Yes.
In version 10.
It was not just in the system context. So that's pretty much it.
What else is not in the system context? But what else? I mean, is there more graph stuff there?
Possibly. I mean, there is. On top of my mind, I don't have a full list on top of my mind.
I mean, we didn't go live with these because, first of all, I think that there's a lot of graph products, for instance, that are potentially really interesting and useful. I mean, they didn't make it for a reason at the time. That didn't seem the most compelling.
I mean, among the 100 and so function at the time, it was not on the top of the list at least. I mean, so
yeah.
Okay, this is some of Nick's work. Wow, that's a lot of graph products.
Yeah, there are a lot of them.
Sounds to me like Nick and Charles should interact here. Okay, and my question is, which Nick is also asking now, I mean, Nick has asked it more clearly first, is aren't there lots of graph sums just as there are lots of graph products?
Same as there's a million of graph operation, everyone can define those, right? So what we define is, what's the most common and what we see people use, right?
Yeah, but okay, but let me be very practical. If you have a 2-argument graph sum, you at least have a fighting chance of not getting tangled with that. Right? Just like graph products, you're doing a 2-argument graph product. You could have an n-ary graph product, right? But you're not. But you are having an n-ary graph sum. I think that if you define it as a binary graph sum, then you can put in that 3rd argument all these different things about whether you re-index it, whether you do all these kinds of things. You might want some default for right now for the 2-argument form, but if you make it n argument from the beginning, you're kind of toasting yourself forever. You see what I'm saying?
Yes.
So I would argue if you make it binary, we're probably okay. And I think graph join should also be binary.
Okay.
And I mean, if we can. My only question is the other graph operations like graph union. They are all. Is graph union n-ary or just binary?
Probably n-ary. It follows the same as our union. So.
Yeah, but there are plenty of. Well, I would make these binary. I mean, I'm not thrilled that this is a bit of a mess because it's basically a potentially n-ary operation, although maybe some of these things will tangle a lot if they're n-ary. Am I making sense? I don't know how tangled these get. I mean, it's like join across, for example, which you could imagine an n-ary version of join across, but it's already complicated enough in binary.
Right. I mean, as Roger pointed out, I mean, we had this operation for a while, and that was one reason why at the time we decided not to push them, and we wanted to actually see how people use them, and all the requests from users.
Well, it turns out that they don't, so far as we can tell, because Nick, for example, didn't know it existed.
It didn't. So. No. What I mean is that we didn't release them in the system contest. We wanted to see, suggestion or.
But nobody would know that they were there.
No, but the question is, did we get a lot of requests for them?
For them before we
and it didn't happen.
Yeah, right. Well, we seem to have at least one fan of graph product here.
No, actually, we got several. I mean, there have been several people, other external people requesting for graph product. So that's why we decided to move it to the system contest.
Okay, well, fine. Okay, so what I'm suggesting is 2 graphs, one, subsidiary argument, which doesn't yet have to be defined for graph sum. Are you okay with that idea? You think that's sensible?
Okay.
Roger, do you think that's sensible?
I think it's okay. I need to run. Unfortunately, I'm already in deep trouble here. So,
well, we'll review the rest of this without you, I guess.
Okay. Talk to you then.
Bye.
Taking off also. See ya.
Okay. Does this follow basically the function repository entry of the same name?
Right. Just to put in context, you remember we had the physics. I mean, it was on your request from the physics project.
Yes.
So
I think I wrote a version of this.
Exactly. So we are going to the list of those constructors and trying to introduce them as you requested.
Good. I mean, I'm not objecting, right? So my only question is here, the torus graph, I think I understand. Should this be called torus grid graph? Or is this actually a torus graph? No, it's a C, it's a cycle, it's a product of cycles, yes?
Right. Yeah, balance between both names. So it's I just picked torus graph because it's the shortest one. But yes, we could call it also torus grid graph.
No, torus graph is probably better. What do you think? Torus grid graph, torus. Are we going to get in trouble with pure torus graph because we're going to want something else to mean that? It's hard to see what else could mean that other than this.
Right, and I think that torus graph is a specific case, right, of this family. I mean, the one people see as it.
Which family?
No, I mean, this torus graph, right, it's, you know, is a family, but the torus graph you are thinking about is like the, you know, the third example there, where is it, you know, you actually see it embedded on the torus. Is kind of what I mean.
I'm sorry, I don't understand. They're all, look, all of these are a grid. Isn't it the case that these are all a square grid that have had edges identified, nodes identified to curl them into toruses? Yes or no?
Yes. But what I mean that when people say torus graph, they tend to also think about the embedding, which we don't, the vertex coordinate, which we don't add here by default, if you see what I mean.
I understand. We might, but I.
Right.
What
But
do you
there
think? I mean, this is a grid graph, and there are different ones, as we can see here, for the
Right.
hexagonal. See, then this will become torus hexagonal grid graph. I kind of think we should do that. I know it's a little bit ponderous, but I think it is more accurate.
Okay.
I mean, what do other people think? Anybody else who has an opinion? We have other people here, right? We didn't all get, but they may have opinions about, just because you're not here for this meeting doesn't mean you can't have an opinion about this. Yeah, I think it should be torus grid graph.
Okay. I think that's...
And now hexagonal grid graph. Aren't there many options for this thing? I mean, having it in its basic form is already a good start, but I still think, you know, there's options about whether you put, yeah, you see, there's options about whether you do this or whether you try to have it be as vertical as possible, right? You know, I could move that guy over to here. See what I'm saying?
Right.
And I thought there were options for this in the rule plot stuff for cellular automata. I thought there's a way of doing this that was defined there. Okay, you know, this is a good start, but I don't think it's the right thing. Okay, there's a good start and we can put it in as an experimental function, but I think we need to, you know, have a little bit more development here. Right? Do you understand the point I'm making?
Right, yes.
Right? There's a version of this that is as if square, as opposed to a parallelogram like this. See what I'm saying? And if you look at rule plot, if we can bring up rule plot, where is rule plot? Wait, what happened here? Why is that? You know, John, I think that when I've been pulling up windows, they are, for the last version or two, with some probability, they're coming up behind what I'm looking at. Am I making sense? John, are you still here? Well, then who's
Yeah,
PM?
yeah. Can you hear me?
Yes.
Yeah, sorry. I threw you to the loudspeaker so I wouldn't have to keep wearing my headset. That the help window is coming up behind other windows.
No, I'm finding a bunch of windows are coming up behind what I'm looking at. But that's been happening for a version or so, is what I was saying.
No comment at this point.
I think it's a bug. I've been meaning to report it. Okay, so this is this question about how these bricks look. And look, let me show you this. Oops, that's not what I want. What do I want? I want this and that. Oh my gosh, that's a bug. Oh, they don't probably want bricks, but then what I want, this case is handled here. Let's see. Parents are hexagons.
Why rule plot?
Because it doesn't do it with array plot.
Huh.
See here, those hexagons are stacked with your parallelogram. And this is the way, this is how lattice plot, for example, works. This requires a bit more thought, okay? The way that lattice plot works is, again, you know, it embeds in a square. Do you understand what I'm saying, Charles?
Yes. Yep. No, I think, you know, we're looking at it, you know, in a precise way. I mean, so if you want a more general function, we can work on it and extend it, definitely.
Yeah. I mean, isn't it the case? Any lattice defines a graph, right?
Yes.
That's how a lattice works. And does lattice data allow you to generate the graph?
No.
Why not?
At the time, we didn't have graph.
Oh.
And I didn't come back and update it yet.
Okay, well, fine. But I mean, so if lattice data, okay, look, we've got several different things going on here, okay? And Ed Pegg is a good person to look at this because he worked on, okay, so we've got these lattices. And the issue is, can we make the graph from these lattices?
Yeah, we can easily make. We have the basis. We know how they are built.
Right. Okay. So that would be very, very lovely to have. Right. The general lattice. Now we've also got in the function repository, at least we've got a lattice plot. Yeah, we should be able to have, you know, arguably, to make things cleaner, we should have some kind of lattice graph. See what I'm saying? Because any one of these lattices will make a graph, right?
Yes.
And it's kind of like making a crystal. You just say the lattice graph, and you have to say the number of root vectors, right? Is you have to give the dimensions in terms of the number of root vector, or the you know, whatever it is in terms of the number of root vectors, yeah?
Yep.
I kind of think that's the function we should have, is lattice graph, and then you say hexagonal, comma, whatever.
Okay, we can work on that and see.
Right.
Yep.
And maybe we can put, I think torus grid graph is useful. I do think that the mixed torus case, where you give, you see what I'm saying, where you know what I'm saying, where you specify some edges are, yeah, there probably should be another argument here that specifies which, if it's torus grid graph, you see what I'm saying? There's a lot of freedom in how the matching works.
Yes.
Right. So if you do that, you can make a Klein bottle. If you have, right. So what you want is you're either not knitting, that's just flat, you're knitting, cyclic, or you're flipping, Klein bottle-y. Isn't there a way of representing this in terms of permutations or families of permutations or groups or something? Jose, is Jose here maybe?
I'm here.
Do you see the question? I mean, so I mean, what we've got, we've either got identity on a given edge. It's either, it feels like it's either none, that is don't connect them, or identity, that is take the list of edges from one side and, you know, look, I think naively it would be, maybe I'm wrong here, none or identity or reverse.
But I'm thinking that perhaps this is just the topology and not the geometry. So there is a difference there in the sense that, do you think there is a sense in which we can distinguish one side from the other side of a surface here or something like that?
You're right. Well, we've got a grid graph, right? And so the grid graph, by definition, has coordinates. Because we've got a grid graph in which we say the first coordinate direction is of length blah, the second coordinate direction is of length blah.
Well, we have a graph with an embedding, but I'm not sure. The graph is more like the topology. The embedding has a geometry, some sort of extrinsic geometry.
No, but what I'm saying is if literally all we're doing in the graph, the level of the graph is this thing has tentacles.
Mm-hmm.
Presumably, it has two tentacles here. Right? It's an extendable grid graph with tentacles on every piece has tentacles. Right? So then the question is, and this relates to the hairs in graph rewriting, is where did the tentacles go?
Well, you can look at it as a quotient operation where you pretty much identified the two sides, right? So from a flat sheet of paper, you can build a torus by just identified the two sides. So that's why.
How do you characterize that identification?
Well, these things would have different topology, and then there are these homotopy groups, etc. These Poincaré groups that can describe topology.
Well, but are you saying, I mean, that's a finite group somewhere, and how would you apply that finite group? Okay, make this creature into a Klein bottle, which you can clearly do, right? You twist the two ends, you identify these two sides, but with these two ends twisted, right? Am I right? Is that the correct thing? If I do a Möbius strip here, okay, how do I make this into a Möbius strip? Answer, I just do this, but I identify, I mean, here I can Möbify this. All I have to do, let me Möbify it in real time. Okay, so to Möbify this, I would simply say, how do I add edges? I just say graph union, right? Or is that going to do something stupid? Is that correct, Charles?
Well, if you want to add, you do edge add. You give the list.
I want to add multiple edges. Can I do that?
Yes, I think so.
Okay, so I want to add, to Möbify this, I want to add 3 goes to 19. I want to go 2 goes to 20. And 1 goes to 21. And do I put these in a list?
Yes, Paul.
Okay. And if I say graph 3D of that, ugh. Well, I probably need a longer one to make it clearer what the heck's going on. But I think this is correct, isn't it? I mean, this isn't very useful because it's crosses over like that. But you see what I'm doing, yes?
Yes. But for me, this is actually distant, and at least that's my view, is that this, graph, torus graph have a precise construction. This has a set of transformation, which should be a different function, where we can give that freedom to, have all those constructor and modifications.
Yeah,
mapping.
Okay, fine. All right, fine. Torus graph is a useful thing. That's fine. I understand. These are getting hairy, is your basic point. Yes, but just for my edification, I mean, this modding out by something, what are you modding out by to get this? Do you understand my question?
Yes. Well, I'm right. I'm looking at it as well. not on top of, I can't see that on top of my head, but if you do the vertex identification, you can pretty much write it as a mode operation, right? So which is
I would
equivalent
think so. It's an
quotient.
equivalence class. It's basically defining an
Right.
equivalence class of vertices.
Yes.
I see. The right way to think about this, guys. Yeah, look, this is the way to think about it. The right way to think about it is simply, I mean, equivalencing vertices. This is not right. What I should have done is define these vertices as equivalent. Right here, I'm adding extra tentacles here, but we could have just said equivalence those vertices. So it's kind of a graph reduce by equivalences. And you've got n tuples of equivalent vertices. Go ahead.
Yeah, the same as you take, the interval 0, 1, you quotient, I mean the square, right? You quotient both sides appropriately topologically, then you create a torus object.
Yeah. No, but what I'm saying is the operation that we want on graphs, I'm claiming, is one where we are defining certain vertices as equivalent. We're reducing a graph by some equivalence relation.
Yes.
Which I don't think we have right now. And that seems like a useful operation to have. In fact, that operation is one that we would have used in the physics project if I'd even thought of it, because that is an operation, that equivalencing thing. Yeah, it's an interesting operation. Nick is saying vertex replace will do identification. So just replacing 3 with 21 or something. Although it seems yeah.
But identification is more than that, right? It's, vertex replace will identify it, but it doesn't. I mean, are you contrasting the vertex, the edges and such? I mean, depending of how you identify, there is also a subsequent operation on the edges, which have to be defined.
I think
in this case, this is kind of a gluing operation.
Yeah, right.
In this case, it would be more than by 18, every vertex.
Let's have this as a separate discussion. We can put this into ILD, discuss it there. Seem reasonable? But torus graph seems fine. I kind of think the hexagonal one should be a function repository item for now. And I think we should go for this lattice graph idea. Does that make sense, Charles?
Yes.
I really like this lattice graph idea. I think that's really nice. It's a good leveraging of lattice data, and it will, as you say, be rather trivial. Right? It should be totally trivial from what we have in lattice graph, lattice data, yes?
Yes.
Let's do it. Maybe we could even do it quickly. Okay, let's see. How does one save an arbitrary infinite graph? Asks LB. It's complicated. I mean, we don't have the notion of infinite graphs yet. We don't have infinite lists. We don't have infinite graphs. Both will be interesting. Enk asks, encounter circular and hexagonal sections of hexagonal grids regularly. Numbering the indices of hexagonal sections is easy. You just add rings of vertices from a center hexagon. Numbering the circular sections is more involved. Circular sections of hexagonal grids. Wow. Okay. That's interesting. Sando talking about toruses with a twist, where the twist is such it's not periodic in one round trip, but after several round trips. Yeah. So it's like the Mobius strip that's been, where the piece of paper has been twisted multiple times. But that just it's mod 2, isn't it? Am I totally confused? No, I'm not totally confused. It just goes back to the same thing. Am I right? Help. Come on, somebody.
Well, it's not just mode 2 because you need to flip the object to
Here we get
to affect the orientation.
Let's try it. Yes, I see. You're right. Obviously, it's like a knot.
Yep.
It's been knotted multiple times. Yes. It's my pathetic 3D visualization sense. I have to actually try it. Okay. I think that's it for graph theory. Is there anything else for graph theory, Charles?
No, that's good.
Oh, we forgot buckyball graph.
Oh.
We talked about that a little bit last time. Is that well defined?
Yes, it's well defined.
These are useful. I mean, there's an argument that this should just be in graph data. What do you think? I think it's useful.
Well, the only argument is that graph data is finite, right? So this kind of gives you the freedom to generate a family of them, arbitrary family size.
No, but graph data has non-finite. Graph data has parameters, does it not?
No, as far as I know.
Yes, it does.
Well, I think we cannot generate a 10 million vertex graph, right?
Well, that's a different issue. That would need, I don't know why, you guys are just allergic to having the right people in these meetings. Where is graph data? Oh, this version is a problem. Well, whatever. So let's get. My gosh, this is not exactly a small function. My gosh. Okay, what's a family of graphs? Anybody know a family of graphs?
Complete graph.
Good suggestion. Look, there you see Cayley tree, for example, 3.5. Okay, let's try Cayley tree 3.6. I believe it can generate families of these things.
No, but what I mean is that I doubt that you can put an arbitrary number.
No, I understand it.
Mm-hmm.
I'm disputing that. I think you can, and you certainly.
In general, I think Eric likes pre-computing things and not computing in real time.
Pre-computed and stored. Right.
That is a really bad error message. That's really bad for 5 different. Okay, this is an LCC discussion. Can we get Eric in the next LCC meeting? We'll talk about this. Okay, seems wrong to me.
Yeah, I can bring that up.
I'm a little concerned about this buckyball graph. I mean, where do we draw the line? I mean, graph data has just a zillion graph types here. Am I making sense?
Yes. Well, last time is me was actually arguing that this is graph data, it should be part of it, and we're more pushing for this. I mean, I think it's a matter of importance. What do we think people, will commonly type or want, right? So if you think that buckyball is that important, then
I think it's fairly common, but you could argue so are some of these other graph types. I mean, I don't think it's cognitively damaging to have essentially graph special functions, which is what we're talking about here.
Yep, we already have a family of them, right? Cycle graph, complete graph, star graph, and such.
And maybe we should have a lot more. I mean, maybe they even come from essentially graph data, and many of these infinite families could then just be special function graph special function functions. All right, let's put in the buckyball thing and let's have the discussion with Eric about other ones. And can somebody at least check this with Eric, please, that he doesn't freak out that we're doing the wrong thing here? Okay.
I'll make sure this gets by him.
Okay, thank you. All right, time to go to segment B. We're not going to get to segment C, astronomy, today, I don't think, but we will get to trees, hopefully. And I think we can get a slot tomorrow, unless I'm completely confused. I think the 2:45 Eastern meeting right now that I have could be moved out of the way, in which case we can continue. We could do astronomy then. I think astronomy is going to be a somewhat long meeting. Do you agree, Jose?
Potentially, yes. And there is another meeting which is perhaps more important, which is this change from data globe to Mapbox. And I would really like to have that as soon as possible.
Okay.
So if we can have that tomorrow instead, that would be great.
Is that a long discussion or not?
No, that's short. That's quite short.
Okay, well, maybe we can do that at the beginning, like 2:45. Then we can spend 15 minutes on that. Then we can go to the rest of it.
Yep, that sounds great.
Okay.
Heard.
Okay, trees. Where's the agenda?
So there was the original agenda prepared by Roger. But I think this time we wanted to review some things that you suggested in the previous meeting and that Ian has implemented in the X kernel.
Sorry. Is there an agenda? Sorry, I lost concentration for a second because I was looking.
Marie just sent an agenda.
Oh, okay, fine. You see, that's the problem. As soon as I'm looking at email, there's 1,000 other messages. More than 1,000, 2,573 to be precise. Just in the middle of working on something which is causing me to be further and further behind. Okay, what are we looking at here? Which was the section here we were looking at? Sorry, you were just saying and I wasn't paying
We
attention.
were kind of jumping around last time. We started looking at expression tree and things to do with unlabeled tree. And so I have some updates.
Okay, so where should I start here?
So this is the prototype.
Yeah, I'm running this in the prototype build.
So do a random tree and apply unlabeled tree to it.
Oops, that's not what I want. That's not what I want either. Unlabeled tree is new, right?
Yep.
It's nice, except that could we get an option, an easy option? Hey, do you really like that of having these? Is that what we do for graphs?
No, so the default tree size is fixed.
No. But I understand. But for a graph, we don't maintain. Is Charles still here?
Yes, I'm here.
Okay, but we don't, for a graph, we don't see this. Right? If I make this smaller, the nodes scrunch down, and that's what should happen for an unlabeled tree. Okay, that's wrong.
Right, let me put some code in chat.
What do you want me to do with this? What do you want me to do with this?
Run it. I put two things in chat.
Okay.
So one of the things you wanted was, in the case where there's no labels, you wanted the nodes to be smaller. So here I'm just using the default graph shape. So that should work exactly how graph works.
I think this is right. I mean, I don't see any reason to, you can see it's a frigging leaf. Right? In
Well,
the case
you actually can't in 13.1. We're distinguishing between an empty list and none in the second argument. Empty list is always round. None is square. And only the square ones are leaves. So you can actually end up with trees without any leaves now.
comments from other people. I like this idea. I think this is a little bit too light, and that's a graphic design issue.
Can you look in this in the first input style equals? There's a darker construct. Currently, I'm using 0.3.
Well, I think
And I just put a third input in chat. We need to make sure that that darkness also works for the labeled case.
wait. What do you mean? Also works? No. You should not do the same thing for labeled and unlabeled. You shouldn't do the same thing. That darkness will not work for the labeled case.
Well, we said last time that we needed to find a compromise that worked for both.
Well, I don't remember that. Okay.
It would be I think it would be strange for the style to change.
That's
just
not
based
going to
on the
work for the labeled case. So do we have somebody from graphic design here?
No.
Okay.
Jeremy's still here.
Okay. Jeremy wants to try to pay attention again.
Yep.
Okay. So let's see the tree without. Oops. Okay, that's our default tree. Okay, now here, if I remove the tree element style here, what happened to the tree element style? And
Remove the tree element shape function.
I removed it.
No, also remove the tree element shape function.
Although I'm quite liking filling the nodes in the case where there is no value for the nodes. You see what I'm saying? In the case where there's no, in the case where, okay, here we've got numbers for all the nodes, right?
Mm-hmm.
As soon as we don't have numbers, I don't see why we're not filling with a darker color. I think it looks kind of stupid to have these things with.
Well, how is this going to interact with actual options? Like if you specify red, or is it going to make a darker red for unlabeled ones?
I don't know. I mean, how does it interact with options for a graph?
The labels and the styles are independent.
Well, you mean labeling as in?
Removing a label won't change the style of the node.
Okay. Let's figure out what to do here. So you understand that the objective is to make unlabeled trees. I don't think that looks very good for an unlabeled tree. I think it'd be better if the thing had something filled here. But you're going to say, well, what if it's a?
Is this a?
What if it's a partially
unlabeled
labeled
tree function, or for any tree that's unlabeled? Because unlabeled tree itself could set whatever options we want if we want to have.
No, I know that, which might be a good solution. Because I think if you have a tree which is otherwise labeled, but something is lacking a label, this is a reasonable way to render it.
Mm-hmm.
See what I'm saying? I just think if the whole tree is unlabeled, what do other people think? It doesn't look particularly good to me. It looks like, see, the problem with this is there's lots of lines in this picture, and there's additional lines here, but it isn't really a line, it's just a point. Does that make sense to anybody?
It does. I thought it was a bug at first, although maybe I'm confusing didn't we have a green, kind of a medium green for nodes for?
We do,
Some
but
point.
there's
That
the
is-
green.
Well, I can't even see it there.
I mean, it looks completely white to me, but I've been told that this is green.
It's green on my screen.
But it's
Really is
much
green.
too light for a, unlabeled. I agree. It needs to just go darker or more or less opacity.
Green
Can
for
you
me
really
as
not
well.
see this as green? on your
I
screen?
really
Why don't you screen capture it
multiple
and let's see if it's green. Screen capture it and send it to us and see if we see green. I mean, whether it's your monitor being badly adjusted or whether it's just some other kind of,
I can see the green.
What's that?
I can see the green. But I have a Mac right now screen.
I see green as well.
But Jeremy doesn't see green, and I bet he has a nice fancy monitor.
I do. It's there, but it's barely there for me.
Yeah, okay. But I think that's sort of okay for this. But as you say, it's not okay in this case here.
Exactly. Yeah.
And so,
Stephen, I just emailed you a screenshot for me. I suspect it'll look green for you.
It looks green. It's green.
Yeah, I sent mine too.
You know, bizarrely, these screenshots look different. Okay, this is really the world is just falling apart, you know, for many reasons. But okay, that's Ian's screenshot. This is Jeremy's screenshot.
Well, I
So-
that's with the edge form applied.
No, I understand, but look at the center. This is much darker green than this one here.
Jeremy's doesn't look green at all.
They're both white. I don't know.
Oh, for goodness sake. Do you understand why this is? Is this because opacity is not being handled correctly on all these different displays?
I don't set an opacity, so I'm not sure.
Okay. All right. So look. Okay. The first thing we should do is when you say unlabeled tree. Okay. I think the correct answer is when you say unlabeled tree, we should reset these things to have both no square leaves. Have you ever seen a tree with square leaves? Unfortunately, lily pads don't grow on trees, so you don't even get circular ones either. But
So
anyway.
can you real quick, can you do tree of empty list and tree of none and compare those?
That should not be that big. It should resize just like graphs do. You should use the same code as graphs do to determine their overall size. Does that make sense?
For this case, for the labeled case, it's trickier because the data is not resizing and the frame is shrink wrapped around it. So
unlabeled tree of a single none is just going to have to be circular. And the circles should be like they do in graph, they should resize with the size of the object for the unlabeled tree case.
Mhm.
Now, given an unlabeled tree, it returns just a tree, but with a bunch of options set, right?
yeah, options removed or set if necessary.
Right, but unlabeled tree returns a tree. So all of the things that I can do where I ask for the uncle of that node will work.
Mhm.
We are also removing the data. Do you want to keep the data of the nodes? So because I was thinking that perhaps this is more like a structure tree. It's another tree that represents the structure of the previous tree. And then we can use any new type setting.
You mean, give me an analogy, like an expression tree, for example, is another type of tree.
Right, because labeling, for example, there are cases in which we want to eliminate labels. You wanted, for example, that lists, the head list that never appears. We just put a small circle so that there are these nested lists cases in which we don't want to see the head list many times.
Nobody's ever going to figure out that. Okay, unlabeled tree unfortunately has a mathematical definition, right?
Yes, but it's a tree that with no data. That's why we remove the data too.
Yes,
It's
which
not-
is right, because
Mhm.
that means that the equivalence classes will work correctly with an unlabeled tree.
Right, exactly.
But I think there's a different kind of tree. I agree with you. There's another kind of tree that shows only structure.
Well, I mean, if we preserve the structure from the previous tree, to me, those are the same. What I was thinking is a tree in which we preserve the data, but we have options saying, do not show the labels.
No, I get it. I get it. But that what I'm saying is that's a tree. Okay, it's not unlabeled tree. Unlabeled tree is what you're making it, which is blow away the data so that the equivalencing works correctly. Does that make sense?
Yep.
But there is a different construct, which is a convenient way to take a tree which has data in it, but where the data is not shown with labels. Where we could recover the labels. I'm making sense. Unlabeled tree, the labels are gone. Right?
Correct. It removes the data. If there are any options, then it specifies none for the labels. And if you have an association, it gets rid of it.
Okay, fine. So you're saying there is another type of tree or another option, another wrapper,
Or
which makes a tree.
Actually, a second argument to unlabeled tree.
Possibly, yes. About maintaining the structure. Yes, that's a possibility. Okay, I should go soon here. Okay, let's come back to this. All right, so we need a color spec for this. Okay, that's the thing, and we need, and I think, let's see, this unlabeled tree operation. Okay, so it could take a second argument.
Yep.
Now you should say removes all data to make an unlabeled tree. To make an unlabeled tree. You get what I'm saying?
Yes. I like that wording.
Okay. So the second argument or is it an option? Like, you know, like the directed edges option of lots of, you know, of grid graph and God knows what else.
Was it directed graph or undirected graph that had a second argument? It was a string.
I don't know. Is there one of those? Maybe Charles can say.
Sorry, what was the question?
So directed graph has a second argument where you can specify a conversion.
Right. I mean, yeah, there's several ways to convert a graph to a directed one.
That's nice. So it's basically no data. Feels more like an option, you know, preserve data, but it shouldn't be called that, true or false. Are we calling it data anywhere?
Yes.
Is that where do we
tree
call it?
data is the function that extracts the data, and we call it the data.
I mean, we could have an option include tree data, arrow true or false. Or is that silly? Or are there going to be other ways of unlabeling things? Yeah, I see. There's also this if we include the tree data, should we have square boxes for the genuine leaves? See what I'm saying?
If they're not shown, then I think the answer should they should either have the squares and for leaves in both cases or not in both cases.
No. Listen to what I'm saying. I'm saying, let's say we say include tree data, true or false, for unlabeled tree. Okay. So in one case, the tree data is gone, right? So in that case,
the question of circle versus square is about tree children, not about tree data.
I know. Well, okay, so we've got these two different orthogonal things. What would you call them? One is whether to include the data in the structure, and the other is whether to display leaves in a special way.
The second one seems like a different shape function option.
Well, we're not going to need whatever. Nobody's going to understand how to do the shape function thing. All right. So look,
We can have a function like unlabeled tree that sets a bunch of options.
we're having a function unlabeled tree. So the question is whether that thing has a second argument or does it have an option that says include tree data?
I think it's prefer a second argument that essentially is like a collection of options, of existing options.
Except for this one about the conversion, which isn't going to be. I mean, what are you going to call the second argument? Unlabeled tree, and then what's going to be? Keep data? That's not a very good second argument. Am I making sense?
Mm-hmm.
Data included. I don't know. What's the second argument going to be? Do you have a suggestion?
Maybe the second argument's a true false.
No way.
No. Should be a string, but yes, it's difficult to choose the name.
That's why I'm proposing include tree data arrow true or false as an option. I mean, that option could even be in tree in general, and it could just drop the tree data if the option is set. So that unlabeled tree becomes the equivalent of, no, that's not right.
You're saying setting the option would delete all of the data?
No, it doesn't make sense. From what I know now, I prefer that option. I don't see a good way of naming the unlabeled tree converter. But if you can come up with a good way, that would be great. Okay. And we need a spec for this. So I don't know if Jeremy has one or it's going to get one or what the story is here. Okay. What else can we look at quickly? How much stuff is there here? Let's get a story about that.
A lot. We need to look at all of these options, and we added a ton of second arguments to expression tree.
Okay. Well, let's look at the things that are simple. Tree leaf count. That a property? Wait a minute, that's just a function, right? Tree leaf count.
Yes.
Okay. Where's the new documentation?
This is it.
No, I mean, but what aspect of it is new?
All of the definitions and notes.
Up here or down below?
The usage messages and all of the notes that you see there in the illustrations. This is completely new.
What did it say before? Was it just incomprehensible?
Pretty much.
Great. Wait a minute. Successively applies F to the data of each leaf up to level N. Adding at most N levels to each leaf, there's the two different meanings to N? I don't understand that.
What?
Look here. It says applies F to the data of each leaf up to level N. Okay, period. That's one thing. That's the top of the tree. Then it says adding at most N levels to each leaf, which seems completely wrong. It's just completely nonsense.
I mean, they're essentially just the same statement twice.
But that's nonsense. It's not adding at most N levels to each leaf.
It is.
No, it's not. It's going down at.
No, you apply the function. You apply the function to each leaf in times, giving a tree of depth in where each leaf was.
So
I see actually, that's right. Yeah.
The thing there is that it could stop earlier. So that's why it says at most.
Okay, so if I take a random tree 5. So the most obvious thing to do is nest tree f comma %54 comma 2. Okay, I understand that. Like, I assume that's the first example you give. Oh God, no! Just
Well-
give this freaking example first.
But f
Not
is supposed
something.
to,
Yeah.
sorry, f is supposed to return a list in general. If it returns a scalar, it assumes basically that you mean the list of that scalar. Right.
All right. Well, maybe you should do it with f and g first here.
Like the second example.
Yes,
Go for
maybe.
that first.
I don't know. Okay, so this is, I see, to the leaves of the tree. There's nothing it does until it gets to the leaves. It's just recursing through until it gets to the leaves.
Yep.
So if I say nest tree of f of this thing here, and I want to start it from the null tree, can I just start that from none?
Mhm.
Well, that's not very good, but okay, so from x, for example, here. Okay, that's nice enough. So how does that relate to nest graph?
So the operator works the same way, but in nest graph, the function's being applied to every node in the graph.
I hope that's an example in nest tree, by the way.
I'll make sure.
Yeah, okay. Okay. Okay, then that's tree fold. Where are the examples?
They're closed.
By the way, Brad Klee has an interesting analog of treefold for DAGs.
That's directed acyclic evaluate.
Yes. Have you been looking at that? Has he been talking to you about that?
It's on my list.
Okay, I don't think the name directed acyclic evaluate is right, but I believe it is basically the analog of treefold for a directed acyclic graph, which is interesting in my opinion.
Mm-hmm.
Is this new or is
I think I understand roughly how that would work, but I haven't looked at his code in detail.
Right. I think one of the issues is how the payload is maintained in a graph as opposed to a tree.
Right. With a graph, this is some kind of like annotation computation thing.
One would assume, and we should ask him about that.
Presumably, yeah.
Unless there's a representation of DAGs that is more like the representation of trees. Yeah. Avery, why do you want me to save down title 1 notebook?
It doesn't really matter. Could be in the trees or graphs folder. This graphs folder right there. Yep, that should be fine. Thank you.
Okay. both the data of each subtree and the list of results for its children. Where's an example of something real being used for this? Being used.
Applications.
So what's this doing?
This is just getting nested lists out of the tree. And then it moves on to showing how you can do things like total the data in the leaves, total all the data, some entity query.
So
type
wait a
steps further.
Oh, I see. Nest tree returns a tree, and tree fold uses the tree like fold uses a list.
Exactly, yeah. Nest tree and tree fold are dual. It's in an algebra.
Really?
Yeah.
In what sense?
Tree fold is basically a homomorphism from some algebra to the algebra of trees, and nest tree is a homomorphism from a coalgebra to the coalgebra of trees.
I'm not sure that helps me particularly, but yeah. Okay.
It roughly lines up with what query calls descending and ascending operators. So nest tree is a descending operator, tree fold is an ascending
Wow.
operator.
Wow. Are we finally going to actually have a meaning for the ascending and descending business of query? That will be
We're working on, so I mean, there's an internal function that nest tree and tree fold are both implemented with that has both descending and ascending operators, but that's not for 13.
Wow. So there's going to be, so potentially, wow. So you can have something which will be the generalization of query for operations on trees.
Because of its generality, it's not limited to trees.
It's like
That was
anything that's tree-like, yeah.
Yeah, like an expression, for example.
Mhm. There's an internal page if you want to look at it.
What is it called?
Expression transform. It's
I'm
not
laughing
really. It's
because
not
that-
really ready for a.
I'm laughing because that's just such an unbelievably generalized,
It's an unbelievably general thing. So. It's not a great name though, I don't think.
To me, the important thing of this function is that it separates the list of ascending and the list of descending operators, which are mixed in query. So this clarifies quite a lot.
Is it well defined? You do one first and then the other, or how does it work?
You do all of the descending in order until you get to the bottom, and then you apply the ascending ones as you backtrack.
But so is that what query does as well, but it just doesn't tell you that?
Well, it alternates. So you get either a descending or an ascending operator per level.
Right, but the difficult thing is
You have two separate lists.
But how do you know in your way of doing it that level 3 is going to get an ascending operator and level 2 is going to get a descending operator?
So every level gets both a descending and an ascending operator.
But you don't have the notion of levels in your thing.
Well,
Yes.
so it's like F0, F1, F2. That's F0 gets applied at level 0, and then F1 gets applied at level 1, F2 gets applied at level 2.
Okay, but so you have to specify. So what you're doing is
And we're proposing an association syntax. It's not implemented to where you could just say level 2, this operator, level 7, this operator. And
I see. But you're saying that query on a given level, can you have only one of ascending and descending, or can you have both?
Well, you can use a composition, and it looks at the composition and looks at each of the operators in that composition and will decide what, it'll do the descending ones while descending and the ascending ones while ascending. So you can kind of specify both.
In what?
In query.
In query, but you're proposing that, I see. So there's nothing theoretically.
I wouldn't use a composition syntax for that in this function. And you could have a composition that's just the entire thing is a descending or the entire thing is an ascending instead of trying to parse it apart.
Yeah, no, I get it. I get it. I mean, but basically what you're saying is that there's nothing array theoretically that prevents one from having combined ascending and descending on a given level.
In a certain sense, it's impossible to avoid. It's just it's like if you think you only have a descending, it's because the ascending operator is like identity.
Yeah.
Yeah.
But it's very difficult to predict which one it is. And for a given operator, query and dataset will have an opinion. This is always descending or always ascending. Well, here,
No, I understand.
we can have examples in which the same operator can be placed in the first list or the second list, and the results are different.
Right, I understand.
Can you scroll down a little bit in the basic examples?
Yeah.
The Saprinsky. I think that's nice. So you can see it's really not like a tree thing. It's a nested structure thing.
Yeah, no, it's very
You never
nice.
construct a tree at any point in this.
It's a very nice construct. It's a very nice object. It's basically a generalization. It's some kind of generalization of map all or map, in which, I mean, map just wraps an F around everything. But what this is doing, which I don't yet fully understand, compare this with map.
So this is actually, so map doesn't use the evaluator, and this does. This is in the nest while and fold family, I think. But the thing with nest while and fold is they're list like. But in nest graph and nest tree, you have this thing where if the operator returns a list, then you go into the elements of that list. And so my claim is when you do that, you get nest tree and tree fold basically.
Okay.
There's lots of properties and relations with like fold and stuff.
That's very interesting. It's a very interesting construct. I mean, this is probably, you know, in the future of arrays discussion, this is probably one of the lost array operations.
Indeed. Yep.
Just in terms of map, though, what is an ascending? I understand your point about map just sprinkles Fs return.
So if map was immediately evaluating, if it was, then I think it would be an ascending operator because it's a bottom-up depth first traversal.
Yes. Yes.
And that's really all the descending and ascending means is you have a depth first traversal. It has a top-down portion and it has a bottom-up portion. And the question is, do you apply the operators while you're traversing top-down? And do you apply them what operators?
Okay, so what happens if you change the traversal order?
I don't think this works with different traversal orders.
Really?
You need the results from your children in order to apply the operator.
So this is a question of having different operators and in which order they are evaluated. Because sometimes when you do total, you have to evaluate first those elements that you are going to add. And those were in deeper levels. So total is naturally ascending. While there are others that you first take a list and break it into parts and then proceed to the elements. So those are naturally descending.
I get it. Yep. All right. But let's a custom meeting about this. Looks very interesting. Okay. So you've got expression tree. And then what are all of these? The labeling and styling and so on. Is this new here?
So the new thing is that tree is now essentially fully implemented. You can have associations of children, and empty list and none are properly handled. They weren't quite handled properly in all corner cases before.
Question. In the case of associations like that, can you explicitly label the edges?
Yeah, so by default it's labeled with the keys, but if you specify label, it overrides that.
Oh, I see. So if I look at this tree, pa, 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 pa. Weird. Okay. All right. So those are on top of those edges. Is that really how we want it? I guess we don't have any choice, but that seems like it hasn't had graphic design applied to it.
That's correct.
I wonder if we could use that drop shadow business on this. I wonder if we could use a background drop shadow to kind of melt out the edge there. Do you get what I'm saying?
By default, or so what if you said tree edge label goes to C? Would the C also have a drop shadow, or would you need to specify it yourself with a manual label?
I would think it would have a drop shadow by default. I don't know. I mean, if Jeremy is still with us,
I am. I think that works until there's, I don't know, you're going to get a lot of density at any point where the drop shadows add up to too much, obscure too much.
Not sure. I don't think so, because trees do have the feature that things tend to avoid each other.
Yeah. I mean, that sounds good. It would just kind of, like you said, soften the edge underneath the label. Yeah.
So, I mean, yeah, please, Ian, why don't you look at it? And I think we'd want it by default for edge labels there.
Okay.
And you're saying if you give an explicit edge label, what does it do? I mean, isn't there an edge label style and so an edge label function and all that kind of thing?
We're adding all of the tree edge styles, or all the tree edge options in 13.1. There's a list on the left.
Okay, good. Okay, these don't look too horrifying. Those coordinates. Yeah, those don't look too horrifying. Those labeling and styling things look like they're.
Yeah.
Are they horrifying? Is there something I should really?
So the two things to point out are, vertex shape function and edge shape function take a vertex name, but the tree versions take data in place of a vertex name. So do you agree with that?
Hold on. Ethan just sent some. How to get all the nodes in a tree? What's the most efficient way to get all the nodes in a tree? What's the answer to that? So if I say random tree, and I just want to get the names of all the nodes, how do I do that?
Tree level, probably.
How would I do that? Do I just say tree level?
Tree level of that, comma, all arrow data.
Splatteroo. That's terrible. I mean, there should be
If you
something
just do
like
all,
vertex
you get the
list.
list of all of the subtrees. Exactly.
Yeah, but so right, but you see, but this is where things get crazy, because it's like we need something that's the analog of vertex list.
I think that's tree position of tree comma blank.
Can we
Is
do
it?
tree level -1?
Like this. What do you know? There you've got it. That's the answer to Ethan's question.
That is a bug.
What do you mean it's a bug?
It should be returning the subtrees.
I was expecting to get trees into which we would then map tree data.
Well, okay, but I think whatever this is, it's useful to be able to get the tree leaves. I mean, if I said tree,
that's why we have extended level specs and tree level, so you can say arrow subtree or arrow data.
And what about tree data with a level spec of -1? That would be clear, I think.
Yeah, I think so too.
Well, we took away level specs and position specs.
Okay, I just did tree leaves and it gave me the same thing, which I'm happy about.
That's what I'm saying. There's a bug.
This is a bug.
Something is going wrong with this. Yeah.
So that should be little tiny trees.
Yes. Mm-hmm.
So if I map tree data over that, then I would get this,
Yes.
as opposed to this with sublists.
Correct.
Okay, tell me the thing you were saying before about tree element and tree whatever. The thing you were saying before that I should pay attention to this feature.
So vertex shape function and edge shape function are graph options where one of the arguments that they take is a vertex name.
Yes.
The corresponding options for trees take position specs instead of vertex names.
Because they're called tree element.
Yeah. Well, because there aren't vertices.
I know that, but they don't use the term vertex, so I think that's okay. But tree edge, what does it take?
I mean,
Tree
so
edge
the
function.
thing that corresponds to a vertex most closely is a position.
I know, so I think that's fine. That's the argument in the shape function there. But what about the tree edge shape function? What does it take? Does it take pairs of positions?
Yeah, the first argument is the points, the point coordinates, and the second argument is the data.
What do you mean by point coordinates?
Like the list x1, y1, x2, y2.
Well, those are absolute x1, y1s, or what? Yes.
However, it works in edge shape function.
Okay. So in element shape function, the arguments are the xy position followed by the vertex name. That's the thing, right?
Mm-hmm.
Okay, that's fine. If that is replaced by well, but now in tree element, you've also got the data, right? So are you feeding that into the tree element shape function?
Yes.
Okay, but that's different from the way that it works for.
Yeah, this is 3 arguments.
Okay, whereas vertex shape function has only 2 arguments. Is that
No, it's
correct?
also 3. It's also 3 arguments, but I'm just replacing the vertex name with the data instead. So I'm using the same arguments except replacing vertices with data.
That seems right. No, except replacing the vertex names by the positions.
No,
but the data.
Right. So on the left-hand side of the rule is a position.
Oh, I see. I see.
In the arguments of the shape function is
the coordinates and the data in your case, or
yes.
the name in this case, in the shape function case. That seems right to me.
Okay. And then the other thing to point out is that we have function versions of options that graph doesn't, and so I want to make sure that they're working as you
like what?
All of the other ones on the left that end in function other than shape function. So we have label function, style function, size function.
Why do we have those when graph does not? Should graph perhaps have those? I'm sorry?
I think you've suggested some of them for graph before, but I'm not sure.
We should discuss that.
I mean, you can achieve all that with a pattern, right? So,
right. It's more important. Yeah, sorry.
Go ahead, Ian. What?
Yeah, so in graph, you have the vertex names, so you can have a pattern replacement rule where the labels and styles and things are just given by transformations of the vertex name.
Whereas?
But for trees, we don't have vertex names. So we need access to those data somehow. So you could say like tree element label function goes to head, and it'll essentially apply head to the data to generate the label.
Okay, in the case of graphs with vertices, you're saying that the list of labels could be a list that's of the form vertex name arrow, what the vertex label should be.
Yeah, you could have a pattern that matches a vertex name.
I understand. Why can't you have a pattern that matches an element position?
In principle, you could, but that still doesn't give you the ability to have a function applied to the data.
Applied to the data.
So all of these things are functions that take the data. So this is a simple mechanism for saying I want all the labels to be F applied to the data.
Can you also have a list of rules that both select by position and then decide on the yes. thing? Okay, that seems reasonable to me. All right, let's look at the
so the next place, I guess, open the expression tree page and start looking at.
Okay, you did this. Okay. I really should get going here.
So we were looking last time at XML and Notebook.
Where is all that stuff? So
Yeah, scope. So the main problem is there's tons of data in these nodes, and we need better default visualizations for them. So this is my first iteration on that since our last meeting.
okay, but I think we also need a lot of options for the notebook thing. I think it isn't just one name here. Do you get what I'm saying? That's what I said last time. I don't think it should just be one thing called notebook. I think it's like notebook import. It should have several. I mean, I think notebook import is a good model for this.
Directly an expression tree, or are you thinking like a notebook tree converter?
I'm not sure. Not sure. I was thinking an expression tree because I think that we can start off with a bunch of named things in expression tree.
Yeah, so we just added the heads option, which works for the arbitrary expressions like head trees, heads. So I guess we could have options in expression tree that only work for notebook.
I don't think it's options. I think it's other named things, not just notebook. I don't think notebook is going to be useful. I think you never want that. There's no obvious default for that. The thing you have there is not a particularly useful thing.
Can you mouse over the nodes?
I don't care. I don't care. That's not the right place to put it. It's just not the right place to put it. Look, the thing that's going to be useful is similar to notebook import, to see an outline of the notebook in this form. So again, it's going to be kind of arbitrary. It's going to be things like section headings with with an elided part of their content, those kinds of things. I mean, the unlabeled tree. Okay, so
so this is the case of take the whole thing and make it entirely into a tree. But I see what you're saying about.
Yeah, it just doesn't.
You may want to have patterns or whatever to make.
Yeah, it's complicated. I mean, okay, so now let's say expression tree of evaluation notebook.
Notebook get of evaluation notebook.
I'm sorry?
You have to do notebook get.
And then here I say common notebook.
Yep.
Yeah, I don't know how useful that is. I don't think labeling it with cell is all that useful. I think it's complicated because we've got this cell group thing, and it's always going to be like a bipartite tree type thing, right?
Yeah, so in particular, the hierarchy here is not the same as the actual rendered cell grouping hierarchy. Like you have a section cell, hello, and it looks like it has a child that's the 2+2. But in reality, the hello cell is a sibling to the 2+2 cell.
Okay, so look, what we really want here is something which is a representation of what you think it should be, right? In other words, this isn't particularly useful. Look at how notebook import does it, because it's much more useful.
Okay.
Right, this is going to take significant work to make this useful, and this is not yet useful. And I don't know what XML looks like. I mean, and I also suspect that these will end up being their own separate functions. Right, so I mean, this should be an import from a website or something. You should be able to get it into a tree. Look, you should be able to get it into a tree, do operations on it as a tree, and then emit it again without it complaining that, oh, you don't have the right header in this place and this thing and that thing. Okay, about my sentiment here. Okay, we're going to have to continue this. I don't know how much of this is really going to get wrapped for 13.1, this expression tree stuff. I mean, it'd be good to have something experimental in there, but I don't think we're going to be able to finalize it. But let's keep pushing on this and pick this up tomorrow or soon. Seem
Okay.
reasonable?
Yep.
Unless you have something else for like 2 minutes here.
I mean, do you want to look at text element or data set or trace?
It's almost lovely, but there's just a lot more work to be done in these. I mean, there's some very interesting stuff here. No question, there's interesting stuff. I think this needs its own proper review meeting. And when you do it, okay, so we're going to need other people. Like for the trace one, we should have Nick. For the data set one, not sure, but for the XML and text structure, where's text structure? Where's text structure?
Above XML.
I don't know. I just don't know. I don't know. I mean, if we're going to go that far afield with text elements, then some of these other ones could be much more you know.
You're referring to the formatting.
Yeah, yeah.
Mm-hmm.
Much further afield there. Okay. Well, all right, to be continued. And we should look at these, but this will take a whole meeting just looking at these things.
Yep.
And we should make sure we have people who are, you know, knowledgeable about these particular subject areas.
Sounds good.
This is very nice functionality. It's great stuff, right? And this, I mean, this really, it justifies the whole trees initiative to see all these things coming together. So it's all good, but take more time. All right, see you all soon.